Okay, so for this problem, we're going to find the x and y components of the force vectors for A, B, and C. We'll start off with A. This one's fairly easy. Looking for x components. Essentially, what we have to do is pretty much just get the magnitude of the vector multiplied by the cosine of the angle. So we're looking for the x component of A. All we have to do is the magnitude of the vector, which is 12 newtons, multiplied by cosine of the angle. And that's going to get you 6 newtons. Now, let's look for the y components. This is also fairly easy, which you're going to do pretty much the same thing. Get the magnitude of the vector, but this time you're just going to multiply it by sine of the angle. It's going to be 10.4 newtons. Okay, now to explain why we're using cosine and sine. Essentially what we're doing here is we have a triangle with a corner angle of 60 degrees. Using Pythagoras' theorem, if we have the length of one side, in this case would be the hypotenuse, we could find the length of the other two sides. This is the angle that we're interested in. This would be considered the opposite of the triangle, the opposite side of this triangle. Since we've already established that this is the hypotenuse, then this makes this the adjacent side, the angle. And then when we're trying to find the sides of the angle, we can utilize SOHCAHTOA. Now what SOHCAHTOA really is, it's just showing us that sine is equal to opposite side of the triangle over the hypotenuse. And this is the one that we usually use to find our y component. Because if hypotenuse is given to us, we can just multiply it, hypotenuse, to both sides. These would cancel, and we'd find the opposite, which is this side, our y component. Now this one is essentially cosine equals to adjacent side over the hypotenuse. And if we're given the magnitude of the hypotenuse, like we do here, all we have to do is multiply the hypotenuse to both sides. These would cancel, and I would find my adjacent side, essentially the x component, which is what I have there. So now we have established why we use cosine and sine. Let's move on to letter B. Essentially what I personally like to do is I like to start originating my angle from the positive x-axis all the way to the end of the vector given. This is going to be 160 degrees, which is essentially the straight line, which is 180 minus the 20. And again, we're going to be looking for our x component and our y component for B. And again, to find our x component, all we have to do is give the magnitude of the vector multiplied by cosine and the degree of the angle, which is this 160. Don't confuse this with the number 8. That's going to give us a negative 14.1 Newton. And it is negative because it's going to be in a negative quadrant. This represents this side. Now let's look for the y component. Again, fairly simple. Looking for the y component, we're going to get the magnitude of the vector multiplied by sine of the angle. This is going to give us 5.1 newtons. And it is positive because for the y-axis, it's in the positive quadrant. Let's move on to C. I have the magnitude of my vector, 25 newtons, with the given angle of 30. Now again, I'm going to start my angle from the positive x-axis, counterclockwise, to where my vector is. Since going counterclockwise from this point all the way to the bottom of this y-axis is 270 degrees, I just have to add the other 30 degrees going this way, which is going to be 300 degrees. So, looking for the x component, we're going to get the magnitude of the vector multiplied by the cosine of the angle that's going to equal to 12.5 newtons. Now, looking for the y component. Again, fairly simple. Again, we're going to get the magnitude of the vector multiplied by sine of the angle. And that's going to equal to negative 21.7 newtons. And again, it's going to be negative because for the y component, it is in the negative quadrant. Now here are your answers. X and y components of A, B, and C.